Welcome to homework.
Hello everyone, today we're doing chapter 29, problem 50, and it says that this toxin, Brucine, is a tree toxin that is highly deadly, and it asks us to show how a racemic mixture of phenylalanone can be resolved using this toxin. So racemic mixture means that 50% of the solution is going to be R and 50% is going to be S enantiomers. So we can draw that out with phenylalanone. So you have the S enantiomer of phenylalanone. And then we have the R enantiomer. So using the same methodology as in section 29.3a, we know that we need to convert these amino acids to the N-acetylated form of these two enantiomers, just so this amine will not be reactive when we're trying to separate these two enantiomers from one another. So if we just take acetic anhydride, then we will form N-acetylated versions of each enantiomer. And then for shorthand notation, this phenyl group, I'll just put in FH for the S, FH for the R. And now we have two enantiomers that are acetyl-protected. And now if I take both of these enantiomers and react it with the R isomer of this chiral carbon here, of this chiral amine here, of this toxin, this Brucine toxin. So if I just take specifically, this is the R enantiomer, if I just take this and add it to each of these, you will get a proton transfer such that this amine here will act as a base and it will pick up the proton from your carboxylic acid backbone. So now if I add in my toxin, then what we see is that we will get a solution that's deprotonated S and R enantiomers plus the, so we'll have the S enantiomer of phenylalanone plus the R protonated version of this toxin. And we'll also have now the deprotonated R enantiomer plus the R protonated version of this toxin. So now what we have is diastereomers. So they are same at one chiral carbon, except they differ at all chiral carbons. So they differ, these ones differ at obviously the phenylalanone chiral carbon. However, they have the same stereochemistry at this nitrogen chiral carbon of our toxin, which exists in both. So now because we have diastereomers, well, now we can separate these based on physical properties. Diastereomers have different physical properties. They have different physical properties such as boiling point, melting point, freezing temperature. So we can exploit these to separate a solution of S, phenylalanone plus the R plus of the toxin, and separate out the R, phenylalanone plus the R plus of the toxin. So now since we have these enantiomers separated, we need to now separate the toxin out of the reaction mixture. So how we can do that is, well, we can just regain our original amino acid by deacetylating this amino acid and hydrolyzing the amino acid to regenerate the amide portion of this amino acid building block. And at the same time, we will deprotonate our acid to regenerate the original toxin that we have here. So if we add basic solution, Now we're going to have a solution that is exclusively the S enantiomer of phenylalanine. And if we do the same thing with our solution, a separate solution with our enantiomer, you will get a solution that is exclusively R phenylalanine. Plus, in both of these, we regenerate the original toxin here, which can be isolated out.